Okay. All right. We're going to be learning about probability today. That yellow page, you're not going to need that until the end. We're going to be learning two different ways that you guys can find probability. The first one is called the empirical rule. That's the easier one where you get to just look at the curve and figure it out. It's pretty straightforward. The ones that we need to use the yellow page for is when the curve is not going to work. So the number that we're using doesn't fit well with the standard deviations and the z-scores. So that's where the chart's going to come in. There's also a calculator alternative to the chart, so I'm going to teach you guys that as well. But I know the chart looks scary, but a lot of people prefer to use the chart than the calculator, oddly. But we'll talk about that in a little bit. So, when you guys have a normal bell curve like this that we were learning last time, we are going to assume that 99.7% of the data is going to fall between 3 standard deviations from the mean. So it's almost 100%. The extra 0.3%, we call those the extreme outliers. Those are on the beyond the -3 and 3 mark, so we have very few points from the data set that far out. Our empirical rule is going to break up the curve into 3 sections for each half. So we have this section, and this section, and because it's symmetrical, it's going to be the same on both sides. So the first section of the empirical rule says that the data will, 68% of the data, let me just double check I have that number right. 68% of the data will fall within the first standard deviation of the mean. So if you guys have colors, that might be helpful for you. What I'm talking about is between here and here, that's going to be 68% of the data. So if you want to use some color coding, between -1 and 1, that's 1 standard deviation from the mean. 68% of your data points will be within that little window. Okay? If we go a little bit further, if we go further out, if we go to 2 standard deviations, 90, oops, that's supposed to be a 9, I don't know why I wrote 6, 95% of the data points will be within 2 standard deviations. So if you go out to the -2 and +2, 95% of your data falls between the -2 and the 2. Alright, so 68% is between the first standard deviations, 95 is between the 2 standard deviations. If you guys go out to the 3, that's 99.7%. 99.7. There's an extra 0.3% that's beyond the 3 and -3, but that's rare, so we don't really think about that part of the draft. So these are the 3 numbers you guys need to remember for the empirical rule. 68, 95, and 99.7. Okay? And it's all based on the standard deviations. Again, the first window is between -1 and 1, the second window is between -2 and 2, and the third window is between -3 and 3. So the questions that they're going to ask you are based on the empirical curve. We'll get there in a second. Just a couple of extra notes. You can actually break down the increments even more because it's symmetrical. You can break it up even more. So we're going to do that in this picture. This is actually the one that's probably going to be most helpful for you, so you might want to draw a little star. Using the 3 numbers for the empirical rule is not as helpful as when we break it down. So you guys remember this is symmetric, right? So if both of these together is 68, what do you think one of them would be by itself? 34. Because it's symmetric. So if both of them together, if that window from -1 to 1 is 68 total, and they're symmetrical, you can cut that in half. So each half is 34. Okay. This one's not going to be quite as intuitive, but if I'm going from -2 to +2, and I know all of that is 95, what would this?
42.5. 47.
Did you just divide 95 in half? Okay. Is that what you did? You just divided it in half? Okay, but that's from here to here. I want just this. What?
Oh, 20.
When you guys cut the 95 in half, that was from 0 to 2. I only want this. 13.5. Mallory, how'd you get that? Yes. So Mallory took the the 95, she subtracted the 68 away. We didn't want this part, which is both of those, and then you cut it in half. That's how you get the 13.5.
I will not.
Right? And then even further out, this little snippet right here. Remember, from -3 to 3 is 99.7. So if you subtract the 95 that I don't want away and then divide that by 2, what do you get? 2.35. So we're basically just chopping it up into little pieces so we can use it a little bit more easily. You remember this? Okay. Then, hold on. Then we have the outliers, right? The outliers are 0.3%, which means that this little snippet right here is 0.15, and this little snippet is also 0.15. Add that to your picture. Beyond -3 and 3, those are 0.15 on either side. What do you guys think the full curve is? 100? 100%? Half the curve? 50. Okay. So the way that we're going to use the empirical rule is they're going to give us some data, and they're going to ask us how much or what percentage of the data falls between here and here. And then you just look at the picture and add the pieces together. That's all you do for the empirical rule, right? So here, they gave us some information. On a previous test, student scores represented a normal curve. After analyzing the test results, we found that the mean was 80 and the standard deviation was 5. We're going to label the curve and then answer these questions, okay? So you can't use the empirical rule unless you've labeled it, just like we learned last lesson. So what number would go here? 80, because that's the mean. And then how do I find the rest of the numbers along the bottom? Add 5 to the right, and subtract 5 to the left. Okay? Now, these questions over here, we needed those numbers because the question is based on that. So 68% of the students scored between what two percentages? Well, 68% is between the 1 standard deviation marks. So between 75 and 85. Remember, your empirical rule tells you that 68% is between the -1 and the 1 standard deviations. So the first little piece right here, so from 75 to 85. What about 95%? The 70 and the 90. That's the second window. From the 2 standard deviation marks in between those, that's the 95%. What about 99.7%? The 65 and the 95. So that's kind of a broad kind of application of the empirical rule, where they could ask you something like that. Does everybody see how I was able to use the empirical rule to apply to that picture? Okay. A different context would be like this. Go ahead and label the picture again. We have 80, because this is a different picture. 85, 90, 95, 75, 70, 65. These questions are going to be a little bit different. That's where you should be labeling the pictures and following along. All right. What percentage of students scored between 85 and 90? Right here. 13.5. That's why knowing the little broken up picture is helpful. So ask for the smaller increments. What about below 75? So it's here and all this way. How do you think you would find that? It is 16. You add everything from 75 below, or does anybody else see another method you could use? Instead of adding 13.5, 2.35, and 0.15, what else could you do? Couldn't you say you could do 50 minus 34? You know half the curve is 50, don't you? So you could do 50 minus 34 because you don't want this piece. You want everything except for that. So you can do 50 minus 34. So there are 2 different ways to see this. You can either add the separate pieces together or subtract what you don't want, either 50 or 100. So there are several different ways to approach it, just whatever clicks faster. Go with that. Right? What about higher than 70? Yeah, 97.5. So again, 2 ways to do this. You guys, you know that this is 50, so you can do 50 plus 34 plus 13.5, or you can do 100 minus those two added together. There's an addition or a subtraction method. Just do whichever one makes more sense to you. Alright, is everybody okay with those so far? Okie doke. Alright, so now we have another one. So I have these pictures already labeled and ready to go. Shading can help some people understand what the question is asking for, especially when they say between. So you can draw the little marks and then shade. So if you guys want to use these for visual guides, feel free. But it's not absolutely necessary. So I have the picture already labeled, and we're going to answer these questions. What percent of ages are between 2 and 4? 34%. That's using the empirical rule. Between the mean and one standard deviation is 34. What percent of ages are between 4 and 8? All that. What is it? 47.5. How did we get that? Yep, you add the two little sections. That's how you get the total. Right? What about between 4 and 10? 4 and 10. 49.85. Why is it not 50? You have the little outlier section, right? You can't say that it's 50 because 10 is not the end of the curve. There's more beyond 10. That's the 0.15. So you can add 34, 13.5, and 2.35 together, or you can do 50 minus the 0.15. Yep. Right. What percent of dogs are older than 4? So that's 4 and then everything to the right. That's 50. That's 50. Notice the word is different. They didn't say between this and this. They said older than. So that's kind of implying infinity. You're going from one point and then infinitely to the right or to the left, depending on the wording. So that's 50%. What percent of dogs are younger than 2? So that's 2 and then to negative infinity all the way. 16. That's 16. That's another 50 minus 34, or you can add the little pieces together. Alright, so you guys see how we can use the empirical rule broken up in the picture? Alright, probability notation. They're oftentimes going to present questions to you in notation or ask you to write the situation in notation. So I'm going to go ahead and show you what that means. So probability notation looks like this. I've written words where numbers should be, or symbols. So the P in the front stands for probability. Inside of parentheses, you're going to have some sort of inequality, like x is greater than 2, or x is between 1 and 2, or something like that. That's representing the question. They're saying, what's the probability of this happening? Whether it's between, greater than, or less than. And then your answer to a probability question represented this way should be a decimal. I know in the ones above, they ask for percentage, so you would write it as a percent. But when they ask for probability, probability is always a decimal. If they ask for a percentage, go ahead and write it as a percentage. If they ask for probability, it should always be a decimal. Okay? So for example, this one right here. What is the probability that a dog is younger than 6 years old? The notation would start with the P, right? Then you have parentheses. So what's the probability of a dog being younger than 6? How do you think I would write the younger than 6 inside of the parentheses? There's going to be a less than 6. What do you think I would use as a little x? Yep. So the probability that x is less than 6, that's how you represent the question there in notation. Justin, are you awake? Okay, keep your head up so I can see your eyes so I know you're awake. Alright, so then go ahead and answer the question. So what's the probability that you have 6 or below? Think about it in terms of percent first. What's the percent like we were just doing? What is it? Yep, 84, because you have 50 plus the 34. That's 84%. If they ask for it in probability, you have to turn that percent into a decimal. Do you guys know how to do that? It's 0.84. You just take the percent and divide it by 100. So it's 0.84 is the probability. So you really have to read the directions to know if they want percentage or probability. Okay? Okay, what about this one? The probability that a dog is older than 8. How do I write that notation? X is greater than 8. Okay? So in the picture, they want 8 and above. Let's write that in percentage first. Then I feel it might be easier for you guys to write it as percentage and convert it. So what's the percent for 8 and above? 2.5. That's 2.5%. But if they want it as a probability, how would I write it? 0.025. Does everybody understand why it's 2.5%? You added the 2.35 and the 0.15 together. Okay. So this little part right here, this was a 34, this is 13.5, this is 2.35, and this is 0.15. You add them together, you get 2. Alright, how would I write this next one? The probability that a dog is between 2 and 8. How do you think I would write that? It's the inequality sandwich. That's the smaller. The 2. We're going to 8 to right like this. There's the smaller number, and then inequality x inequality, and then the bigger number. Okay. So in this picture, they want between 2 and 8. What's the percentage for that? 1.5. You can add the 68 plus 13.5, or 34 plus 34 plus 13.5. How would I write that as a probability, though? 0.815. Never round. Not ever, ever, ever round for probability. Alright, so everybody see how I can write it in notation and find the probability based on the percentage? Everybody okay with that? Alright, so the empirical rule is nice, right? It's awesome. But it only works as far as you guys have information that falls exactly on a standard deviation. What if I had asked about something like 3 or 7 or 9? You can't use the empirical rule then. That's where that yellow chart comes into play. So you can use the empirical rule when your information, the numbers they're referring to, are exactly on the marks along the bottom. If the number they're referring to is in between the marks, you cannot use the empirical rule, right? So when it's between standard deviation marks, you cannot use the standard deviation, or sorry, the empirical rule. Instead, we're going to be using that idea with the chart there. Okay, so this is what we're going to do instead if we have something like that. So here's a question I'm going to present. What percentage of dogs are younger than 5? Is 5 an exact standard deviation mark? No. So can I or can I not use the empirical rule? You cannot, because we don't know how to break it up any more than what we've done already. So the data point is smaller than the increments of the empirical rule, right, than it allows for. So instead we're going to be using z-score. We're going to be using z-score in a probability chart, the yellow thing that you guys have. We're going to be finding the area under the curve. That language is important if you guys move on to pre-calc or calculus. Finding areas under curves is something you do a lot in calculus in particular. Alright, so this is how. We're going to find the z-score. You already know how to do that. Formula's right there. We're going to find the z-score. Then we're going to find the z-score on the chart you guys have. So the chart that you guys have is a list of all the different z-scores that you guys can have. One side's positive, the other side's negative. So we're going to look for the z-score on the chart. And then whatever... I'll explain how the chart works in a second. These are all the probabilities. The z-score is created using the top and left-hand margins. And then you kind of go into the chart to find what the probability is. So the inside part of the chart is all the probabilities. Along the outside, that's how you create the z-score. And then that's all you really do. So we're going to go with that question with the 5. So let's find the z-score. If the data point is 5, what was the mean? You have to look at the chart. What was the mean? 4. And what's the standard deviation? 2, right? So we're going to find the z-score for the data point of 5. So 5 minus 4 is 1. 1 divided by 2 is 0.5. Alright, so find the z-score. 0.5. This is how you guys are going to use your chart. I want you guys to go to the chart that has positive z-scores. You can tell by looking along the left-hand margin. Alright, you want the positive z-scores, so you want to be on the side that has the positive z-scores. What you're going to do, this is 0.5, and I'm going to add a little extra 0 here, just to make it a little bit easier to work with the chart. You're going to go on your chart where you see the 0.5, which is right here, right? Did they have an extra number after that besides 0? No. So then you would go in this column because there is no second decimal, and then you're going to go to where they meet. That's your answer. So the answer is, let's write it in percent. That's the percentage, oh sorry, that's the probability. How would you write that as a percent? 69.15%. As a probability, you just leave it as the decimal. Alright, so typically the z-score is going to have 2 decimal points. That's why they have the top margin and the left margin. The left margin is the first decimal point, the top margin is the second decimal point, and you go to where they overlap in the chart. Okay? In probability notation, if you guys see this, the probability that x is less than 5, what's the probability that x is less than 5? 0.6915. If they ask for probability, that's when you guys would write it as a decimal. Right? These two mean the same thing. Right? They mean the same thing, but what's different about them? What's different between these two? This one has an X, this one has a Z. This one is talking about the data point. See how they said the data point was 5? That's why they use X. X is the data point. I want you guys to write this. Data point. Alright, so one notation is based on the data point. This one's based on what? The z-score. So the answer is the same, but they both mean, or they both are referring to the same answer, but they're presented differently. You're asking for the probability when the data point is 5, and the probability when the z-score is 0.5. Those mean the same thing. Okay? But the notation is going to be different. So you have to pay attention to whether they're referring to the data point or the z-score. You have to look at to know which one they're referring to. Okay? So we have a couple of examples using the chart on this, right here on the next side. What percent of the dog's ages are less than 7.9? Okay, so let's go ahead and write the notation really quick. All right, how would I write this in terms of x? Okay. Now, is 7.9 an exact number? This is all based on the data we saw on the previous page. It was not, right? It was like 4, 6, 8. 7.9 is not an exact standard deviation, so we have to find the z-score. So we're going to do 7.9 minus 4 divided by 2. This is all the same data as we've been using since last class. Okay? So what would the z-score be for that? 1.95. So what you guys are going to do is go onto your yellow chart, positive side. You're going to go to 1.9 along the left, and then the extra 5 along the top, and then go down to where they meet. 0.9744. That's the probability, right? So were they asking for the probability? They're asking for the percent. So you can write down the probability, but that's not the final answer. Now you guys need to write it as a, write it as a percent. Always read the question to know whether they want the probability as a decimal or they want the percent as a percent. Alright? Now this is how you guys wrote the notation in terms of x. How do I write it in terms of z? Probability that z is less than or equal to, actually. Less than or equal to what? No, because 7.9 is the data point. Nope, 1.95. Because that's the z-score, isn't it? We found the z-score was 1.95. If you guys are using x, you're going to use the data point that they gave in the question. If they're asking for it in terms of z, you're using the actual z-score that you just found. Big difference between the data point and the z-score. Alright, let's reset. What's the probability that a dog is less than 3.24 years old? Is that an exact standard deviation where I could use the empirical rule? No. So I have to use the z-score rule instead. So 3.24 minus 4 divided by 2. Same data as before. The z-score is negative 0.38. Alright, so then you want to go to the negative side this time. You want to flip your chart over to where the negatives are. You want to go to the negative 0.3 on the left, and then the extra 8 along the top. And then see where they... Anybody have it? 0.3520. They always present it in four numbers. Alright? Now, do they want the answer in probability or percentage? Probability. So I can just write down the decimal. I honestly don't know why those curves are there. You don't need them unless you're trying to gauge stuff, but you don't need them. Alright, so you guys see how you use the chart? Positive and negative. One thing I want to make sure you guys are clear on is that chart you guys are using only works if it's a less than. It only works if the wording says less than. So the values in the table are set up for this. I don't want to circle that word. It only works directly from the chart if the question is referring to a less than. If they change it to a greater than or between in the question, you can still use the chart. There's just a little bit of extra work you have to do. And I have that listed right here. Okay, so if it's a less than, you just use the table probability, right? But if it's a greater than, you're going to do 1 minus the number that you found. So you can still go to the chart and find a number, but if you see that it's a greater than, you should do 1 minus that number, and that gives you the answer. So if it's a greater than, you want to do 1, which represents 100 for the full table, and then subtract away what you found from the chart. Okay? So let's go ahead and try these, and then we'll move on to the between in a second. This is the one where you guys just get to use the table, right? What does this mean? The probability that the z-score is less than 0. So you guys, if you see less than, go straight to your chart. Find 0. They told you what the z-score was. You don't have to solve for it. That's what's nice about this notation. You don't have to solve for the z-score. They gave it to you. 0.5000. Right, when the z-score is 0, that means it's on the mean. So anything less than that is 50% of the curve. Alright, this one again, did they give it to you in terms of the data point or the z-score? The z-score, so do you have to solve for the z-score? No, they gave it to you. Alright, so don't solve for z-score. They gave it to you already. You just look for that in the chart. Go to the negative side, because it is negative. Yep, 0.0643. Okay. So less than is pretty straightforward. You just have the z-score, or you solve for it. If they don't give you the z-score, look at the chart, write it down. The difference between that and this one is that you guys, when you find the number from the chart, you have to do 1 minus that. Okay? So again, did they give me the data point or the z-score? The z-score. So do I have to solve for the z-score? No, you go straight to the chart. So I want you guys to go ahead and find on your chart the probability for less than. That's what the chart's going to give you. So what's the probability if I go to the negative 0.17? Okay, so that's not your answer, but I still want you to write it down. 0.4325. Sorry. Alright, that's not my answer, because that would be the probability for less than. So how would I get it to be the probability for greater than? no, it's 1 minus 0.4325. That result will give you the final answer. 0.5675. That's how you get the result for a greater than. 1 minus the less than from the chart. Right. Same thing over here. Did they give me the data point or the z-score? Say again. What's wrong? What's the question? This? I did 1 minus the probability that we've heard the probability we found previously. This is the probability you found in the chart, right? But that's that's the probability for less than. They were asking for a greater than. So if you see a greater than, sorry guys. See how the symbol says greater than right there? Yeah. If it's a greater than, you have to do 1 minus that number to get the final answer. Okay? So if you guys see that this is another greater than, what's the probability for the less than? 9463. That would be your answer if it said the z-score is less than 1.6, but I want greater than, so you're going to do 1 minus 0.037. Yep. So the only thing that's different is you have to do 1 minus the number if it's a greater than. So you're trying to get the rest of the curve besides the less than part. Okay? Now, when you guys have between, it can be a little bit more work. So you have 2 different z-scores that you're working with. Okay? So the way that you're going to do this is you're going to do the probability of the z-score for the bigger number, and then you're going to subtract away the probability of the z-score for the smaller number. Okay? So you have to figure out which one of these is the bigger number. Alright? So I want the probability of the z-score for the which one of these is the bigger number? The 2.1. So you guys want to find the probability of the bigger number first and write that down. So what's the probability for z being less than 2.1? Yeah, 9.821. Correct? Then you want to find the probability of the z-score being 0.1. What's the probability of 0.1? .5398. Are you confused on how we got those numbers? Yeah. Okay, well, you treat it like it's 2 separate questions. You pretend that the z-score is a 2.1. See how 2.1 is bigger than the 0.1? You kind of write the numbers in reverse of how they've been presented. So if you want to draw little arrows. You're going to find the z-scores in the opposite order of how they're presented. Okay? So the z-score for the probability for the 2.1 goes here, and the probability for the 0.1 goes here. Right? And then you subtract them. Subtract them from each other. You should get 0.4423. Is everybody getting that in your calculator? 0.4423. That's the answer. The reason why we have to do the bigger z-score first is because that's going to be the bigger probability. Your answer should always be positive. So if you guys are doing this question and you accidentally get a negative number as your final result, you have the numbers in the wrong order. Okay? Just remember that your answer should always be positive for a probability. Always. So if you accidentally put them in the opposite order and got negative something, you did it wrong. Your answer should always be positive. Alright, so over here we're going to do the same thing. I need to find the probability for the 3.1 first. 0.9990. Then I need to find the probability for the negative 1.2. 0.1151. Subtract those. Yep, 0.8839. And remember, your answer should always be positive. So if you get a negative, that means you just need to switch the order of the numbers. Alright? So if it's less than, real easy, just pull it out from the chart. If it's a greater than, you have to do 1 minus that number. If it's a between, you have to find the 2 and subtract them. Okay? And this is all when you can't use the empirical rule. If you can use the empirical rule, feel free. You can even do this if you, actually I don't want to say that, because I'm pretty sure for the SOL, if you can use the empirical rule, they expect you to use the empirical rule instead of this. So if you can use the empirical rule, make sure you're doing that. This is only for when you can't use the empirical rule. Right? Now, this you guys can ignore. If you like the chart, is there everybody comfortable with the chart? You see how it's not too scary? There is a calculator way that you can figure it out in your calculator, so I'll just show you, but you don't have to use the calculator method if you don't want to. A lot of people prefer the chart. I'll just show you, you guys can follow along. So what you want to do is go into your calculator. Okay, you go to second, and then there's a button that says VARS, V-A-R-S. You want to hit second VARS, and then you want to go to the normal CDF. 2, right? And then push enter. Okay. Now, there are different situations. There's the less than, greater than, in between. So what you're going to do is if you have a less than, which is right here, you always have your lower bound, upper bound, the mean, and the standard deviation. Those are the information, that's the information you're going to enter into the data. So if your lower bound is negative infinity, you would have to write -1, so type in -1, and then second comma, should give you an E. Should give you a little E, so we see the E, and then 99.
So same thing.
It's at,
Oh, it's right here.
Right above 7.
right above the 7. Comma is right above the 7. So in your calculator, it should look like this. -1, and then pushing second comma gives you a little E, and then push 99.
I already had it on my
Oh, it's already there? Okay, so some of the higher level calculators will already enter it for you. Then you actually, instead of pushing second comma, you just push regular comma. Or if you guys have, you can scroll down if you're doing the upper bound. And then they're telling you that the z-score is 14, so you push, or sorry, 0.14, so 0.14, comma 0, comma 1. And then you push enter. I'm just saying, this is the way you can use your calculator. I like this a lot better than using the chart. Alright, and then this is the number you guys would get. You would just use the first 4 decimals.
No,
So the lower bound already set. The upper bound is whatever the number is that they give you.
Wow.
Those of you who have the TI-84 are in much better situation because they already have the lower and upper bound set. It's just this number that they give you is the upper bound if they say less than. If it's a greater than, the infinity, the 1 to the 9, or 1e99 is the upper bound, and then if it's between, you don't have to use infinities. You just do the smaller number, the second number, and then 0, 1. So that's how you guys can use your calculator. If you're interested, you can practice doing that. If you're not interested, you can just stick to the chart and remember the rules. The reason I like this is because I don't have to remember the 1 minus thing for a greater than, and I don't have to remember to find 2 z-scores and subtract them in the correct order. It takes the thinking out. You just have to remember what's the upper bound and lower bound. And the calculator figures out the rest of it. That's why I like it, so I don't have to remember the different rules. But, again, it's up to you. So if you want to work more one-on-one to really understand how this is working, we can talk about that one-on-one to make sure you understand the technology if that's something you're interested in. Otherwise, you can just use it. You do not get to take those home. You can find them really easily online though. Just look up for the z-score table. Z-score probability table, it'll pop up. Real easy to find online and use that for your homework.
Oh.
Okay? Questions?
You just always type in the upper.
It changes on whether you want less than or greater than. Okay? Questions, questions, questions? Again, a couple things I want you guys to make sure you have very, very clear. You have to use the empirical rule if you can. If the numbers are exact standard deviation marks, you have to use the empirical rule. The only time you're allowed to use the chart there is when it's not on an exact standard deviation. Okay? You guys need to know how to write the notation, the probability, in terms of x and z, because that's going to be on the quiz. And you guys need to read the directions to know if the question is asking for probability or percentage. Lots of details to make sure you're looking out for in the directions. Okay? Alright, so we have about 10 minutes before class ends, so you guys can start working on the homework to make sure you understand it.
Isn't it